Hello everyone! Kotlin Coroutines 1.5 is out. Concurrent and non-blocking code is the industry standard today. And in Kotlin, coroutines are the bread and butter for asynchronous programming. Whether it's server-side or mobile apps, you can leverage coroutines for handling asynchronous tasks. My name is Anton Arkhipov. I'm a developer advocate at JetBrains, and today I'm going to talk about the new features in Kotlin Coroutines library version 1.5. There are four major topics in this release. First of all, the global scope is now marked as a delegate API. Global scope is an advanced API that is easy to misuse, and the compiler will now generate a warning about the possible misuse and require opt-in for this class in your programs. Coroutines timeout annotation is now available for JUnit 5. We introduced new non-suspending functions in the channels API, and we also developed a new naming scheme that will be used for the new library functions. The integration with the reactive Java frameworks is getting stable. We added more functions for converting from the reactive streams types to Kotlin flows and back, and stabilized a number of existing functions. Let's dive into each of these topics one by one. First, let's talk about the changes to the global scope. Global scope is used to launch the top-level coroutines that operate on the whole application lifetime and are not cancelled prematurely. Active coroutines launched in the global scope do not keep the process alive. This is a delegate API that is easy to misuse. Let's take a look at the example where you might have used global scope incorrectly. For instance, there is a function that makes a network call. This is the place where you might want to launch a coroutine. Often, global scope was used to bridge from synchronous world into a synchronous world. The problem here is that a coroutine launched in a global scope is not a subject to the principle of structured concurrency. So if it hangs or gets delayed due to a problem with the network, for instance, it will stay working and consuming resources. Starting from coroutines version 1.5, it is still possible to use it to launch new coroutines, but you will see a warning. In many cases, the use of global scope should be avoided by marking the function with suspend keyword. In cases when global scope was used to launch multiple concurrent operations, the corresponding operations should be grouped with coroutine scope instead. Alternatively, we can provide the scope for launching a coroutine either as an extension function to coroutine scope class, or by passing the scope as a parameter for the function where we need to launch the coroutine. Often, your coroutine scope corresponds to an entity with the predefined lifecycle in your application. In this case, all coroutines started in the scope are automatically cancelled when the corresponding entity dies. Such scope, if defined as a member property, is available for all the member functions automatically. If you would like to learn more about this topic, I suggest to read the blog post by Roman Yelizarov about the coroutine context and the scope. There are limited circumstances under which global scope can be used safely. For instance, if you want to launch a top-level background process that must stay active for the whole duration of the application's lifetime, we recommend reviewing all the usages of global scope in your programs carefully, so you could keep only those that fall under the legitimate use cases category. Please consider replacing such usages of global scope as described previously. Let's see what the new release brings for working with JUnit. Sometimes we have to write JUnit tests where we need to access some external systems on the network. And there is never 100% certainty that these external systems will be available while executing the test cases. That's why it is advisable to use JUnit's timeout annotation while writing the test cases with external dependencies. In the new release, we have added coroutines timeout annotation that allows running tests in a separate thread, failing them after the provided time limit and interrupting the thread. The annotation is similar to JUnit's timeout annotation, but it adds some coroutines machinery to the test execution. For instance, in case of a timeout, the coroutines dump will be printed to the standard output. Previously, the coroutines timeout annotation was available for JUnit 4. In this release, we are adding the integration for JUnit 5 as well. Let's talk about the integration with reactive streams now. Reactive streams is the initiative that provides the specification for asynchronous stream processing. And there are popular frameworks that implement the specification in the JVM ecosystem, such as Project Reactor or RxJava. You might be already using some of those libraries in your project. So it is essential for coroutines to provide integration with the existing libraries, so you could introduce coroutines gradually in your project without having to migrate all the code at once. In Kotlin, we are using Flow for asynchronous stream processing. While Kotlin flows are different and the types are not compatible with the ones specified by reactive streams standard, there are still conceptually streams, so it is possible to convert Flow to the reactive publisher and vice versa. Such converters provided by the coroutines library out of the box and can be found in the corresponding reactive modules. There is a number of functions that we managed to promote to the stable status this time. These include the convenience functions for working with types from Project Reactor and RxJava, and some extension functions for converting between the different types. It is now possible to convert a type from reactive streams implementation to Flow and back. For instance, new code can be written with the coroutines, but integrated with the old reactive code base via the opposite converters. For instance, the new code can be written with coroutines, but integrated with the old reactive code base via the converters. Here is an example of integrating with the observable type from RxJava, and there is the same example for working with Flux from Project Reactor. Changes in the channel API is the big theme of the new release. Channels are important communication primitives that allow us to pass data between the different coroutines and various callbacks. In this release, we have reworked the channels API a little bit. An important achievement is that there is now a new consistent naming scheme for the library functions. As a result, some new functions were introduced. Try_send and try_receive are the new non-suspending functions, replacing the offer and poll functions that were causing confusion previously. We tried to work towards a consistent naming scheme to further use it in the libraries and coroutines API. We wanted to make sure that the name of the function would convey the information about its behavior. As a result, we came up with the following. The regular suspending functions are left as is, for instance, send and receive. Their non-suspending counterparts with error encapsulation are consistently prefixed with try. So we have try_send and try_receive. And the new error encapsulating suspending functions will have a suffix catching. One coroutine can send some information to a channel, while the other can receive this information from it. Both send and receive functions are suspending. Send suspends its caller coroutine if the channel is full and can't take any new elements. Receive function will suspend if the channel has no elements to return. Let's see how the code executes. We first create a channel instance that will be used to pass the data between the coroutines. Next, we launch a new coroutine which will be sending the data to the channel. The invocation of the launch function returns immediately. So we continue with the print line statement. Currently, there is no data in the channel, so the coroutine suspends for now. Next, the coroutine responsible for sending the data wakes up. It prints the message, and the coroutine would suspend if there wasn't a receiver, but this time it is not the case and the element will be sent to the channel. The coroutine completes, and finally the main coroutine receives the element. The corresponding non-suspending functions are the new try_send and try_receive. Both of them return channel result. If we execute this code, we will see value failed printed out as a result. This is simply because we try receiving first and fail because there is nothing in the channel. And try_send fails as well because there is no receiver. In essence, whenever a suspending operation would suspend a coroutine, the result of a non-suspending operation will be a failure. In this example, this is happening because the capacity of the channel is zero. This kind of channel is also known as a rendezvous channel. Let's execute the same example, but the channel will be closed. Sending to the channel will fail, and the result will indicate the root cause. The old functions, offer and poll, were causing a lot of confusion. The names of the functions did not convey the information about their behavior. In addition, handling the result of the offer function wasn't really convenient because you would need to remember what do true and false mean. So now, if you have any invocations of offer or poll functions, after upgrading to Coroutines 1.5 you will see a deprecation warning. Since offer returned a boolean, its equivalent replacement would be calling isSuccess on the channel result. However, note that the overall behavior of the new methods is different regarding error handling. So if your code was relying on offer and poll functions throwing exceptions, please see the release blog post for the details of how to migrate. In addition, starting from this release, the error encapsulating suspending methods will have suffix catching. For instance, the new receive catching function handles the exception in the case of closed channel. In this example, the channel is closed before we try retrieving a value. However, the program completes successfully, indicating that the channel was closed. That's it. Let's reiterate what's in the new release of Kotlin Coroutines. The global scope is a delegate API. Please review the usages of this class in your applications and consider better alternative as suggested. You can now use Coroutines timeout annotation in your JUnit 5 tests. In Channels API, we have added the new error encapsulating functions. When you upgrade to the new version, please review the documentation for instructions about the migration. And finally, many small improvements were made to the integrations with reactive streams. Most of the functions were made stable. Upgrading to the new Coroutines version is pretty simple. Make sure you upgrade to the new version of Kotlin first, and then use the 1.5 version of Coroutines or any of the dependencies required either for reactive streams integration or testing. As always, your feedback is appreciated. For more details on the subject, please refer to our blog and to the documentation. Thank you for watching. I hope it was useful and have a nice Kotlin!